Alright, time for another draftphysics.com, debatephysics.com also, but you can't get anywhere. So anyway, this is number 3, video number 3. Stick 3 fingers up here in a place they can be seen. That'll do. Anyway, so the first two, well, one got nailed for a copyright strike, so I have now augmented the video, and we'll see how that goes. I have played hundreds of these videos of people and never gotten a copyright claim. Even Professor Lewins, who sold his content rights to a company, even that company didn't, attack me with copyright violations. So the BBC has decided to up the game. So, the stupid process they do, it's completely illegal. I mean, you're supposed to be allowed to publish something and then they have to sue you. That's the process, okay? It isn't this preemptive, annihilation of the content kind of thing. You're supposed to allow a person to do their thing and then pay for it if it's actually a crime. You have to let them commit the crime before you can convict them of the crime. It's kind of the principle in the law. Well, anyway, so they totally screw all that up. So they tell you you've got a copyright violation, but they're not going to give you a strike. And then they give the company 30 days to reconsider their claim. And so at least they did it quickly in one day. But they're basically, the BBC is saying that somehow I am violating their copyright by doing an hour and a half commentary on of mine on a video. And it's just bullshit, and there's absolutely nothing in this performance art that is in some way protectable from counter argument, and so it's clearly fair use. So instead we'll do it this way. So if this is what you'd prefer, so instead of a regular image of him, we'll do this. If that's how they want to play the game. I don't think they're going to win, okay, but whatever. So I have to decide whether I want to take the risk of getting a copyright strike, which is not the end of the world, but frankly, this is the kind of stuff YouTube uses to annihilate your channel. So all you need is, one violation, and they'll turn it into 3, and without even trying, and all of a sudden your channel's terminated. So there is a risk involved. So I have to consider my options. And so we'll try this first. If this works, then I'll just distort the other video, and we'll see if that's good enough to evade this draconian censorship by the British Broadcasting Corporation and this Al-Khalili bullshitter. So anyway, that's what'll have to happen. So it's not my fault, their choice, blah blah blah. I tried to be fair and decent, and they won't have it. So this is what you'll have to look at instead of the actual video, by their choice. All right. I did change the speed, so I sped it up a little bit, and instead of compensating for the voice, I said, go ahead, fuck his voice up too. It'll just make the point even clearer. This is how they would prefer the argument to be made. So it's just such bullshit. I mean, not to be able to counter-argue of a steaming piece of propaganda is just such bullshit.
As we gazed up at the heavens, we asked where we had come from.
So this is more crap about somehow they're answering the questions of where the universe came from. And it's just, number one, it's just a silly question, okay? We know where we came from, okay? We came from fucking fish. And the fish came from something even dumber, and they came from something even dumber, and that's where we came from. Ugh. And that's all you need to know, frankly. There's no other story that means anything. Whatever, why there is fucking matter and force in the universe there's just no point in asking the question why, because it's going to be a dumb answer. It's not going to be Because God thought it was a lovely idea. That's not going to be the fucking answer.
How all the stars were created, how all the elements were made, even how the universe itself had begun. One of mankind's greatest achievements is that we've answered these questions.
Fuck you, you have. You've answered them with a story. A fucking story based on evidence you can't show me. You just tell me that you have all this evidence, but you can't show me any of it. Like it taking 25 times the fuel to spin a motor 5 times as fast. You can't show me your proof of that. Ugh, pathetic lying scum.
What is truly remarkable is that this understanding has come through the study of the smallest building blocks of matter, atoms.
So that's the silly part, right? That some of this connects to the two things connect in any real way. They really don't connect in any real way.
As we peered inwards, we realized we could explain what we saw when we peered outwards.
So they haven't even figured out what is outwards, okay? I mean, all of this black hole nonsense where somehow the matter piles on top of the matter and it all occupies the same piece of space. I mean, really, you think they have evidence that that can happen?
The atom has helped us solve the greatest mysteries of existence.
So again, isn't that just an amazing statement? Do you feel like they have solved the mysteries of our existence? Do you really? You think they have a really great answer? I don't think so. You know, it went bang once, and then it got super big, really quick. Instantly super big. And then it got slowly bigger. Because space keeps filling in all the gaps somehow. Yeah, space keeps being made. So stuff is getting further apart because there's space being poofed in between everything. Except for the atoms. And there's no new space between the Earth and the Moon. But there's new space everywhere else. Ding-a-dong-dong, ding-a-dong-dong, ding-a-dong-dong. Oh, God, I can't stand it. We're going to do some
Everything in the world we see is made out of tiny objects called atoms.
Right, and the atoms are made out of electrons and protons, so we already know all this. Okay.
And yet we only proved their existence at the beginning of the 20th century. The first shock was to discover how small they were, less than a millionth of a millimeter across.
So all of this was talked about, you know, for hundreds of years. So it wasn't like a huge surprise that we started getting more and more evidence that indicated that, yes, there was something elemental. All right. And then it was clear that that something elemental was itself had parts. And that's where the game stops, essentially, because those parts look pretty without any nuance. Every electron is like every other electron, and every proton is like every other proton.
There are trillions in a single grain of sand. Amazingly, we now have a pretty good idea of the number of atoms in the known universe.
So this is the silly part. Who would even waste their time trying to figure this out, right? So I guess they've tried to do some cubics of space, and we don't even know where the end of the universe is, and yet they just want to make up a silly number for no good reason. A silly guesstimate.
Now, given the vastness of the universe and the minuteness of the atom, it's not surprising that this is a mind-numbingly huge number. It's 1 followed by over 70 zeros.
I would have guessed more than 70. 70 zeros doesn't mean much to most people because they don't really get the fact that it's exponentially larger with the addition of each zero. You know, it's a huge increase when you keep 71 is huge versus 70.
That's a trillion, 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 trillion.
Times a trillion. So if I add another zero, oh, times another trillion.
Atoms. We don't only know the raw number of atoms in the cosmos. We also know...
This will get to something, don't worry. Okay, there's bullshit in the beginning. So far, absolutely nothing about physics or science. Just, you know, mush.
That they come in 92 different flavors. These are called the elements, and you'll recognize many of them as familiar parts of the world around us.
So the elements are basically nucleuses. That's how they're described, defined, all of that crap. But there's a bunch of, okay, where you can just add a little, subtract a little, and you create an isotope that's very similar to that atom, but it is distinctly different in the sense that a lot of those are radioactive. They're not stable nucleuses anymore.
Oxygen, iron, carbon, tin, gold, and so on. Everything in the universe, the stars, the planets, the mountains, the seas.
The universe is the subnuclear world. That's the real only universe. So the atom is full of the same empty space that's out there. And they're the real only things doing anything. So everything that I'm doing, electrons and protons did it first. Every word I speak, everything that happens because electrons and protons are being manipulated by their associations with each other and how they've been arranged in these different configurations, and that's what's causing everything. But yes, it's so goddamn fucking small. We just, it's almost impossible to really think about all the roads. It's a map with 1,000,000 trillion little roads on it, and so we can't really follow along. But the fact is, it creates stuff emerges out of it that is insanely complex.
The animals, you and me, we're all made of these atoms, or combinations of them.
So we're made out of electrons and protons. That's what we're made out of. The atoms are, it's a real concept, don't get me wrong, but it's like telling the difference between a duck and a frog. It's not enough of a difference to matter.
It's an astonishing human achievement that we now know not only how many atoms there are in the universe.
It's just silly. We know it.
And how many different types there are, but why they exist at all.
So he's saying he knows why they exist. It's just hilarious. But anyway, their whole entropy argument is that it's all falling apart. And the reason why the atoms exist is because there is gravity and it crushes, electrons and protons into nucleuses, atomic nucleuses. Suns make nucleuses.
We can now explain how every one of those trillion atoms was created.
What a pile of crap. So obviously the idea of creation, it has to imply some kind of starting point. You don't have that answer. You just have it just recycles. The sun breaks it to pieces, shoots out a bunch of pieces, they collect the pieces get crushed together. It's just a cycle of crushing and breaking and crushing and breaking.
It turns out that the answer to the mystery of creation itself lies within the heart of each and every atom in the universe.
So he said that like 3 times, some kind of wooey statement about blah, blah, blah. So it's just this wooey. Why is that the question you're dealing with? What you should be dealing with is the physics.
The story of how we came to understand creation itself started over 100 years ago in a small laboratory in southeast Paris.
The really bad part about this, I think this particular video is the worst, is the stupid sound crap is so loud you sometimes can't hear him. So if I feel it's necessary, I will tell you what he said, because you can't hear it over all their production bullshit.
This piece of paper is a remarkable artifact. It's from the notebook of the woman who first studied radioactivity, the chemist Marie Curie. It's incredible, 100 years...
So she was working in the same lab, it just happened to be, with Becquerel, the guy who really discovered radioactivity. And so she's more famous for the pursuit of radium, because it was a predicted element from their perspective. It should be there, and they spent years, exposing themselves just horrible conditions, to find the element. And it was so powerful in terms of its radioactivity that you couldn't even see the stuff. You know, you had tons of ore and you get almost nothing for your trouble, but it's highly radioactive.
Later, and this piece of paper is still spitting out radioactive particles. Still stuck to the paper are tiny but intensely radioactive particles of a substance that Marie Curie discovered in 1898. A substance she called radium. It was a sensational discovery for one primary reason.
Well, unlike all the rest, it creates more alpha particles than anything else. Helium nucleuses fly out of it. So what it's breaking down into just happens to produce a very big chunk of radioactive junk. A collection of electrons and protons moving at a high speed. Let's put it that way.
Radium looks like an unremarkable grey metal. It contradicted all the then known laws of science. Because radium pumps out invisible yet powerful rays of energy, which could fog sealed photographic paper and burn human flesh. Also, radium appeared to contain within it an inexhaustible store of energy. Curie worked out that a gram of radium, a piece much smaller than a penny, contains more energy than 100 tons of coal. To the scientific community, radioactivity was just about the most exciting thing possible. The brightest minds of a generation clamored to study it.
So you can see the music's just way too loud, and you can't fix it. I tried, changing what speaker it comes out of, and can't do it. So it's really annoying. Really poor production values there.
And the price of radium, its most potent source, soared to thousands of pounds per ounce.
So yeah, it's very expensive because you gotta go through an awful lot of ore to get a little tiny bit.
And radioactivity didn't disappoint. In 1919, it produced its greatest revelation yet.
So everything's always the greatest. Everything that happens is the greatest. It was the greatest moment in science history. There's like 700,000 of these greatest moments in scientific history. This is such hype.
A revelation that would ultimately lead to a fundamental understanding of the atomic world.
So this is a fundamental understanding. They think you can pile all the electrons in the universe into one space in the universe. I mean, it's idiotic. And there's a bunch of antiparticles somewhere.
The revelation was that radioactivity allowed humanity to fulfill an age-old dream. To become alchemists.
So in some sense, all right, so look, the chemistry part is a little bit, you can change water into oxygen and hydrogen. So from a 500-year ago perspective, that's alchemy, okay, in a way. But anyway. The funny thing is they kind of already knew that all of this is going to take an awful lot of energy to do any of this stuff. So if you wanted to make gold out of something, you're going to have to use so much energy to do it that you're not going to make a profit.
Alchemy. The power to change base metals into gold. The quest for the so-called philosopher's stone, which has the magical ability to transmute one substance into another, has been an obsession for centuries.
So this really is, again, not a real physics subject. This isn't physics.
It conjures up wonder.
I mean, all this hype about it, it's a simple process we know now. All you're doing is changing. You're adding or subtracting a couple of electrons and protons to a nucleus. So but the fact is there's rules about how you do that.
For tales of sorcery and wizardry, as anyone who's read Harry Potter knows very well. The power and wealth that would surely come to anyone who mastered alchemy seduced many great scientists and thinkers, like Isaac Newton, Robert Boyle, and John Locke. All of them tried to change one element into another, and all of them failed. Then in 1919, the secret of alchemy, the mystery of the Philosopher's Stone, was finally revealed, not in a wizard's den, but in the physics department at Manchester University. The world's first true alchemist was Ernest Rutherford. A loud, straight-talking New Zealander, Rutherford had come to dominate the study of radioactivity. He had wonderful intuition and was fearlessly prepared to challenge conventional wisdom.
So you probably haven't seen the previous video, so but yeah, they tell the same story over and over in each one of these. So there's 3 of these different videos. I probably do them in, 2 or 3 parts each, so it all gets kind of distracting. But anyway, it is kind of funny that the same characters come up, and the way they're described are, it's almost like they're talking about different people.
And alchemy would require Ernest Rutherford to follow his intuition deep into the unknown. The discovery was almost accidental. It began when one of Rutherford's students noticed that when radioactive materials like radium were placed inside a sealed container of ordinary air, mysteriously small amounts of the gas hydrogen begin to appear. Now, this was bizarre. Ordinary air contains virtually no hydrogen, and yet in the presence of radioactivity, it was appearing out of nowhere. This was precisely the kind of problem that Rutherford, now at the height of his powers as an experimental physicist, loved, and he flung himself at it. He began by isolating all the different gases that make up the air we breathe.
Right, so it comes just down to they found that nitrogen is the one that is being changed, from nitrogen into oxygen, and it's releasing hydrogen.
Nitrogen, oxygen, water vapor, and carbon dioxide, and studied how each of them behaved in the presence of radioactivity. And then, eureka! Rutherford realized that in the presence of powerful radioactive rays, the gas nitrogen, which makes up about 80% of the air we breathe, changes into 2 new substances, the gases oxygen and hydrogen. Then and there, Rutherford had transmuted one element into 2 others. He'd become an alchemist, and radium, with its powerful radioactivity, was the Philosopher's Stone. The press hailed Rutherford as the first alchemist, but in fact that was the least of it. What alchemy had shown him was the inside, not...
You can't hear him. It's just hilarious. But anyway, so again, all this height, yes, very good. Experiments are great. It's great to discover how to do something. So now they figured some stuff out, and they had to figure out that the alpha radiation, the nucleuses, of helium that are flying out of the radium, if you can slow them down, they do this even better. So the fact is you want them sometimes to combine into a nucleus rather than just break the nucleus.
Just of the atom, but of the strange object at its center, its tiny beating heart, the nucleus. To get a sense of this achievement, remember Rutherford and his contemporaries at Cambridge had only a sketchy idea of what an atom was, but they did have an idea of its size. And it's mind-numbingly tiny, 1/10 of a millionth of a millimeter across. Let me put it another way.
All right, so this is something they say, but I'd argue that maybe they don't have really good evidence that this number is exactly right. And part of the problem is that when they take our atomic weight and then they, compare it to our real weight, the 2 don't add up. So somehow your electrons and protons don't have enough weight, to be you. And they really have to have enough weight to be you, because frankly they're all that's inside the atom.
There are more atoms in a single glass of water than there are glasses of water in all the oceans of the world. And Rutherford now also knew that the atom had structure, that within the atom there was a subatomic world. He pictured each atom like a tiny solar system. At its center was an object which Rutherford called the nucleus.
So this is the same video that, the same clip anyway that they had in the other video. And again, they said that Rutherford was the what the hell was it called? The fruitcake model, whatever it was. It was some kind of model that didn't involve orbiting, okay? And that's what he was famous for, and somehow it was Bohr who came up with this solar system crap. So he's telling a different story here than the other stories that have been told. So that is sort of surprising. Because Rutherford, the little bit of his writing I have seen, he did argue for the existence of electrons inside the nucleus. And that was before they knew what the neutrons were, okay? And the fact that now they will concede that neutrons are composite objects and they contain a proton and an electron when they decay, well, then obviously that's the electron in the nucleus is the neutron. It's carrying an electron. And so that's where this gets really weird, because Rutherford knew this. Okay, he knew there was electrons in the nucleus. And so what happened next doesn't make much sense.
Orbiting this, like planets, were the electrons. But what on earth was the nucleus? Rutherford was convinced that alchemy had shown him the answer. To understand how Rutherford did this, we have to get inside his head, to think like he did. Rutherford had fantastic intuition.
Right, so it's just, this is all this, the made up part, you know. You have to glorify the story and change, you know, and it's all kind of bullshit.
Coupled with an intensely practical approach to science. So he hated ideas that relied on complicated mathematics.
I agree with
When
him
it came
there.
to the atomic nucleus, Rutherford looked for the simplest idea that worked. And what worked was to imagine that the
So they're sort of implying, so Rutherford's doing his work, and for part of this time, Bohr and Rutherford were in the same laboratory, so for 4 years or so. And, you know, he just pointed out how he hated mathematical models, hated and, you know, Bohr was all about just abstract bullshit. Nothing was real, everything was just a number, blah, 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 blah. So it's hard to believe those two people could get along.
nucleus is made of tiny, rigid spheres, like snooker balls. Using this incredibly simple image, Rutherford could construct all the elements in the universe. He could explain how the huge variety of different atoms are made of the same basic components. So here's how it works. Hydrogen, which is the simplest element, consists of just one sphere, which Rutherford called a proton, which is the Greek word for first.
Right, so it doesn't make much sense, that part, right? Because, you know, it's not really a single proton isn't an atom, obviously. And so it gets complicated because hydrogen has these different forms. So you can have hydrogen that's in this elemental form, and then you can have hydrogen 2, you know, which means it's molecularly, the hydrogen exists as two atoms stuck together. And so, you know, it's more complicated than just saying hydrogen is this, because hydrogen isn't in just one form.
All the other elements are made by adding more protons to the nucleus. It's as simple as that. So helium, which is the second lightest element, comprises of 2 protons. Lithium has 3.
Right, but the key point is it has more than that. Okay, so helium has 4 protons and 2 electrons in the nucleus. That's a helium nucleus. So, you know, you have to count what the neutron is contributing.
Carbon, which is the element that's the basis of all life, has 6 protons. The oxygen that we breathe has 8. And uranium, which is the heaviest naturally occurring element, has 92 protons.
And it has something like, 57 neutrons. So it doesn't have an equal number. So when you add it up, it doesn't come out even. And that might be one of the reasons why it's radioactive, is because it does have a huge imbalance between the number of electrons and protons. There's a 3-to-1 rather than a 2-to-1 relationship.
Was Rutherford's inspirational idea that each element is defined by the number of protons in its nucleus.
And that, like I said, it would be interesting to see the periodic table rewritten with the actual numbers of actual protons, that is, counting the neutrons as a proton and an electron. I'll have to do that someday.
It's a wonderfully elegant and simple idea, an idea that explains how so much of the universe we see around us is constructed.
It's perfectly useful in terms of recognizing the more stuff you're creating in the nucleuses, the bigger they're getting. You're making them out of a constituent element, hydrogen. You're making them out of a constituent relationship. But I would argue the constituent relationship is first you have electrons and you have protons. Then you have neutrons, which is those two things isolated. That is, in some sense, protected from the universe by being very close together. While they're a little bit apart, they're jiggling so much that it's hard for them to get together. And it's only with intense pressure, that is really intense heat, okay, that you can force them, okay, to get close enough where now they're not going to be disturbed by much, because their pressure holding them together is so strong because they're so close. It's like two magnets stuck together, really hard to pull apart. Really easy to pull apart if they're still not stuck together, but once you let them stick together, really hard to pull apart. Same thing. The magnetic model would work so much better. So if they would have stuck to north and south, and understanding electrons as the north and protons as the south pole of the universe, okay, magnetic modeling would be so much better. But even the electrical model works in the sense they already know what a charge is. They know proton, electron. They know those two things want to be together.
But as scientists...
Oh, it's just such a shame I violated the copyright of this, such important stuff I'm giving away to the universe here.
often find nature is never quite as simple as it seems at first sight.
It's simpler than what you seem to see, okay? They seem to see ghosts and hobgoblins and all kinds of pixies, all kinds of bizarre and wacky shit. I don't see any of that crap, frankly.
Sure enough, a big problem emerged with Rutherford's proton. And it was to be one of Rutherford's own protégés who was the first to identify it. Francis Aston was an interesting character. As a young man, he enjoyed the adventurous outdoors and was into skiing.
Who cares about all this? See, they do this with each character. They got to do this little blah blah crap about their personal life. Like it's a physics argument. Come on, just tell us about the physics. Who cares about these personalities?
Motor racing, and apparently in about 1909 he discovered surfing off Waikiki Beach in Hawaii. But he soon realised that the call of the physics laboratory was greater than the call of the waves, and it was while at Cambridge that he invented an incredible piece of equipment. That's now housed here, in this rather austere and plain-looking building, the Cavendish Laboratory.
So it's really not all that incredible, right? So this is just the argument that, okay, you got these alpha rays that have way too much energy, right? They bang into stuff and annihilate it. And the fact is if you put those rays into some other substance, you can create other rays that are less intense and will do less damage. So you can slow these pieces, these bits down. And the idea is what you're basically going to do is create some neutrons. Instead of helium atoms, now you have neutrons. And the neutrons can be added or subtracted from a nucleus as long as they're not going too fast. It's all about just subdividing the energy and making it more useful because it isn't too aggressive.
This is Aston's original...
I mean, it's not much different than thinking about a nuclear power plant, and the fact is that you're causing this huge reaction and you have to dissipate it into something more useful, something less hot.
Spectrograph. It's an amazing piece of equipment because with it, for the first time, scientists were able to weigh individual atoms. It's incredible. It looks a bit like a gun. It's a very strange shape. Now they could weigh atoms accurately. They discovered that there was a fundamental problem with Rutherford's model of the nucleus. Basically, the numbers didn't quite add up. All the atoms of the known elements, apart from hydrogen, were much heavier than they should be. For instance, helium with 2 protons should weigh twice as much as hydrogen with just 1. In fact, it's 4 times as heavy. Rutherford realised this could mean just one thing. Apart from the proton, there's something else inside the atomic nucleus. But what?
So again, Rutherford already speculated about electrons being in the nucleus. I don't know why I can't remember what the fucking stuff they called it. The cupcake model. I can't remember. Anyway, the implication is that the atom was just a blob of a mixture of protons and electrons.
It took 12 years to find the answer. Now, as head of the prestigious Cavendish Laboratory in Cambridge, Rutherford threw all his resources into the project.
All right, it took 12 years, is what he said, and Rutherford put all his resources into it, head of the Cavendish something or other. So it is just hilarious that they couldn't have gotten this volume thing right.
He bullied and cajoled students and researchers until one, James Chadwick.
So some kind of James Chadwick was one of the students. So because I can barely hear it, so it's just a piece of garbage. They spent all this money and then they let some sound engineer fuck the whole video up.
The nuclear physics equivalent of gold. Chadwick built this in 1932, and to think that with just this tiny little piece of equipment, he discovered the missing ingredients of the atom. For me, as a practicing nuclear physicist, this really is an amazing device. When I think of the huge accelerators that are built today to conduct experiments to probe the nucleus of the atom, it's really awe-inspiring in its simplicity, really. He put a source of radioactivity at this end of the tube, and the radioactivity then struck a small target in the middle here. And then, out of the target came new particles that sprayed out of this end here. It's a bit like an atomic gun shooting out Rutherford's missing particles. What?
So you're just converting the big helium nucleus into smaller momentum bits, putting it into... That'd be the interesting part, to see if they play with kinetic energy. Because, yeah, they'd end up with a lot more kinetic energy coming out than they put in.
Chadwick discovered was that along with the proton, there's another kind of particle inside the nucleus. It weighs almost exactly the same as a proton, but is much more elusive because it carries no electrical charge. Technically, we say...
So I would argue that they don't have these numbers right. So this is they think the electron is, this 1/2000th of the weight of a proton, but they measured the weight of the electron by using 1/2 mv squared. So in their experiment, they're using the velocity of the electron and its deflection, and with mv squared, they're ending up saying its velocity is a huge component of its energy rather than its mass. And so they have a way underestimate of the electron's mass. If they used momentum, okay, the electron would weigh a lot more. Now, I'd still say there's a differential, but it might be a 2-to-1 differential, not a 2,000 to 1 differential.
It's electrically neutral, hence its name, the neutron. And it immediately solves...
So the neutron isn't neutral, and they already know it decomposes into an electron and a proton and an anti-neutrino bullshit. So they already know this. So why are they saying this crap, that somehow the neutron is a particle that's neutral, when it's clearly a dipole? It's clearly the first little magnet, and it's the only pure magnet in the universe.
The problem of the weight of atoms. So helium is 4 times as heavy as hydrogen because along with its 2 protons, it contains 2 neutrons. And oxygen has 8 neutrons along with its 8 protons, making it 16 times as heavy as hydrogen. So in 1932...
So if they had done that correctly, it would have just shown that there was going to be twice as many red balls as green balls. And then your obligation is merely to create a geometry where it's red, green, because that's what the nucleus is going to end up doing, is creating the smallest, tightest arrangement of those elements.
The atomic family was complete. Scientists announced that every atom in the universe is made of just 3 basic components. Electrons.
So the right answer, I'm just saying, The right answer is it's only made out of two elements, and it's just electrons and protons, charge, and charge explains everything. It leads to everything else.
Tiny particles orbiting a nucleus, which in turn is made of protons and neutrons.
So this is what they had to copyright, was this reenactment of the neutron play. See, who cares? Is this important? Do we have to know that some idiot did a play about finding neutrons? That's not part of the story, is it?
Over Christmas 1932, physicists at the other great centre of atomic physics, the Niels Bohr Institute in Copenhagen, celebrated the neutron's discovery and the completion of the nuclear trinity by writing a musical about it.
That which experiment has found, for theory had no part.
I can't remember if he said Bohr wrote it. I don't know. Couldn't tell what he said. But anyway, who cares?
Is always reckoned more than sound to put your mind and heart in. Good luck, you heavyweighters, that's we welcome you with pleasure. But passion ever spins our plot, and Gretchen is my treasure.
Some of the great names in physics took part in this musical. Their excitement was primarily due to one thing. They knew
That just proves the scientists were silly turds.
they stood at the threshold of an entirely new kind of science with entirely new rules, what we now call nuclear physics.
Mush. Bullshit. Yeah, I don't know.
The first challenge for nuclear physics was this. Although physicists now knew what the tiny nucleus was made of, they couldn't explain how it all held together.
Okay, so they knew what it was made of, but they couldn't explain how it was all held together. See, this is the part where I'm saying, come on, this can't be the real story. They know what charge is. They know how it works. Okay, the two red things repel each other, the two green things repel each other, and the green and the red attract each other. Why don't they recognize that simple function? I mean, that's a really old function. Newton knew about that. So why wouldn't you just understand that, oh, you found the elemental charge, okay, so you saw charges behaving 200 years ago, so you knew the idea of plus and minus, okay? I mean, even though Benjamin Franklin assigned it wrong, he knew what it was, okay, the idea of it. That, your negative charges are being piled on a place, then it's more negative, and now this is positive, and the two will attract. So why would you sit there and say there's some sort of problem? We can't figure out how electrons and protons stick together. What do you mean you can't figure out how they stick together? I mean, it just doesn't make any sense.
In fact, it was worse than that. The existing laws of physics predicted that every atomic nucleus should self-destruct instantly.
Okay, so the physics predicted that every atomic nucleus would self-destruct by their wacky assumptions that don't make any sense. That somehow electrons moving have to do work, when that's just nonsense. Now, the fact is they're dragged to a halt, okay, and that's an important fact, that the elemental bits can't fly through space, that I can't make an electron gun and shoot electrons to the moon. That's an important fact.
Neutrality pulls us along.
I just wonder how much money they wasted on that crap.
The main problem was this. All protons, the key ingredient of the atomic nucleus, have positive electric charge, and things with the same charge repel each other, just like these magnets.
Right, and if you turn the magnets around, they attract each other really powerfully. I just don't understand this. I'm sorry, but this is incomprehensible to me that this could be anything to do with the truth. There had to be some other reason they couldn't figure out how charges behave. Because once you know, okay, that, like Rutherford, that there's electrons in the nucleus, you understand what's holding the nucleus together. It's kind of obvious.
Look,
It's insanely obvious.
so just like
It's not even very good magnets, you know, that's kind of funny too. They spent all that money on that stupid play, and they didn't spend any money on, well, get some neodymium magnets that really fly apart fast.
these magnets, if two protons get close together, they should then just fly apart. But weirdly, inside the atomic nucleus, they don't.
Right, because there's an electron between them. Duh! I mean, I just don't know how that couldn't occur to anybody just to say, well, what if I put an electron between the two protons? Oh yeah, then I don't have to use any strong force at all. They'll just fly right into the electron and just sit there. I didn't have to do any work at all. And then if I knock the electron out with a little bit of burst of energy, right? Quick little bing, and it's gone. And then the two protons will be sitting next to each other saying, I hate your guts, blah, 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 blah. They'll be talking about each other's mothers and army boots and shit. And they'll be flying apart at, you know, a high acceleration. Exactly what you see. That the structure is dependent on the geometry being balanced. And as soon as you imbalance the geometry of the objects, it flies apart. Duh. I mean, it makes perfect sense. I just don't understand how they could see this as a hard problem to solve.
Dozens of protons can stick together alongside each other. So what sticks?
So we know they're not stuck together. They're not in the same place, right? Why don't they use their singularity nonsense and just say they're in the same place, so they can't bother each other because they can't see each other because they're both in the same place, right? If I'm in the same place, I can't find the other guy offensive, can I? Because I can't see him anymore.
Them together? What stops the protons from flying apart? The answer
The answer is the electrons that are on the other side of the nucleus. I mean, the neutron.
was big news. It was nothing less than an entirely new force of nature.
So they just invented it, right? So they didn't discover the new force. They didn't find it. They didn't video it. They didn't do any of that. They just made it the fuck up. They just made up a fake idea that there's this fake force out there that shoves protons into each other. I mean, it's a silly answer. It's just made up. They just said Ghost did it. Ghostly Ghoster. So that's what they, instead of the strong force, they ought to just call it Mr. Ghostly Ghoster did it.
For centuries, humans had only ever encountered two natural forces. Gravity, which pulls us down to the earth, and electromagnetism. But now...
So electromagnetism covers a lot, right? So that's all the photons, all of that stuff, and magnetism included. So that's a little bit nuanced, frankly. Okay, there's a lot of nuance in that, where gravity is dead simple. Okay, that's just this obvious differential you're in. And so the explanation is are you being pulled into the earth, or are you being pushed by the universe? And the obvious answer, you're being pushed.
hidden inside the atomic nucleus was something completely...
And of course they chose exactly the wrong. Every single time they had a simple yes or no, they always guessed badly. They always picked the wrong answer. They always filled in the wrong little hole on the fucking paper.
new. It was called the strong nuclear force.
And it was just a contrivance. We had to have an explanation, so we just made up something that we don't have to account for. We don't have to explain where it came from. We'll just say, you know, bent, nuclear semen. We'll just make up something.
And the easiest way to imagine it is with some Velcro.
So this is just too silly.
If I put Velcro around these magnets, they start to behave slightly differently. At first, they repel each other just as before. But when they get close enough, the Velcro kicks in and they stick.
Yes, amazing. So you still need the thing to push them into each other. So what's the difference? Just keep pushing them and you don't need the Velcro then. So this doesn't explain anything, because now you have a strong force that pushed them together. So you still have to have the strong force to push them together. And all you're saying now is that, well, yeah, and once I use the strong force to push them together, the force disappears and the whatever force, the glue force, takes over. So now you're inventing a second fake ghost. So you have one ghost that pushes them together, and then some other ghost holds them together. I mean, how is this an explanation? How is this a rational metaphor or analogy for the event when the event is just as simple as just stick an electron between the two protons and they'll move right into each other?
Effect is very short range, but very, very strong. And it's exactly the same with protons. The strong nuclear force explains what holds the nucleus together.
So it doesn't explain anything. Let's understand they're forced to provide some explanation of what this strong force is, they say the word gluon. So they just make up this magical particle that basically sticks to one thing, and then it shoots a thing to the other thing, and then it's made out of some kind of rubber band thingy, and so then it pulls the protons together. That's their fucking explanation, and they say they understand reality. It's nonsense, it's silly, it's worse than the biblical Holy Ghost. It has absolutely no credibility as an entity. There's not supposed to be ghosts. How can you have a holy one? Ding, ding, ding. It's got deliverance now.
The strong nuclear force works between all protons and neutrons. But what is...
So it works between all protons and neutrons. So how did he involve neutrons in this, in the strong force? No explanation there.
truly surprising about it is its strength. It's by far the most powerful force in the universe.
So let's understand, it's the same force. So we already know, he just showed you a magnet. It's the same force repelling as it is attracting, okay? You know, the forces are equal. Now they do say that there might be a slight difference in the north side, might be a little more powerful than the south side. I've heard some talk like that, but I don't know any experiments that demonstrate that. So we know that the force pushing electrons apart is just as strong as the force pushing protons apart. Blah, 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 blah. The only difference being is that, yes, the protons, if they are heavier, it means that the repulsive force has to be in some way to create the same momentum. Well, if it creates the same velocity, it would create more momentum.
More than a trillion times stronger than gravity. Think of...
So again, it's really not. So these are fake comparisons because obviously gravity is based on how much of these electrons and protons you have. And it's not based on a, you know, you can't really make a comparison with something with trillions and trillions of bits to one bit with one amount. So it's just not a fair comparison.
About it this way. If I was pulled down to the Earth, not by gravity, but by the strong nuclear force, then I'd weigh trillions of times more than I actually do.
Right. So we just know, we know that, yes, one particle, one electron can't produce much gravity, and it takes trillions and trillions of them for it to illuminate into an amount of substance. You just can't compare one molecule of water to an ocean and say one isn't as wet. Well, it's not as wet because, yeah, it's only one.
In fact, I'd weigh more than the entire galaxy. But the reason I don't weigh that much is because the strong nuclear force is only felt down at a distance of a trillionth of a millimeter. With the strong nuclear force, humans finally began to get a glimpse.
So it's just kind of nonsense because you know that these objects are able to stay quite a distance from each other and still affect each other. So charge, you know, it does degrade by, I think it's the inverse cubed rule actually for a dipole. But for the charge itself, it's the inverse square law. And so it does degrade with distance, but obviously we can see charges function for quite a bit of distance. You know, the Venn diagram machine, different things can show you that, yes, the charge, you know, matters. Distance doesn't blow it up. It degrades it, but it's still pretty significant force.
Of what was actually going on inside the atomic nucleus. Roughly speaking, all nuclear behavior is down to a balance between the strong nuclear force.
So there's no strong nuclear force. All there is charge, and the balance is that obviously I can arrange charges in a geometry where they'll balance each other. So I could have two electrons here, and I could have another electron here, and you could have a proton here. And obviously there would be still attraction to the proton, but there'd be repulsion with the electrons. You know, this is in part half of a helium nucleus. And they would be in tension with each other, and it would be durable. You could poke on it and it wouldn't fall all apart, because the forces would compensate for any changes in the distance. If I bring the electron closer, the electrons push harder on it, okay, and push it back again. So everything would be in a tension that would work.
Squashing the protons and neutrons together, and the electric charge on the protons forcing them apart.
So the electric charge on the protons forcing them apart. So we just said charge is the force pushing them apart. So there's no strong force pushing them apart. He's saying charge is doing it. So the strong force is overcoming the charge force, which is makes it even more incredible that it's overcoming the strength of the charge force, which is going to launch the objects and give them these incredibly high velocities.
Physicists realized that picturing the nucleus as a battlefield between different elemental forces solved one of the oldest mysteries of all time.
All right, so this is just too silly. It solves nothing. It's a made-up solution. It might as well just say the invisible man did it. You walk into a trial and you say, no, my client's innocent because the invisible man murdered the person. It's that bad. It's junk. It's worse than pseudoscience. It's just, this is religion. This isn't anything that could be called science. They just made up crap. And it's a crappy answer.
It's this, a question that humans have asked ever since the dawn of time.
Oh, I hate this crap of telling us what we've been interested in. Sorry. This homie don't play that.
Is how does the sun shine? Now sunlight is a...
So this is the other part where they just got it all wrong. Because, well, all the sun's doing is destroying things. So if I throw something into the sun, it's going to be annihilated. It's going to be burned and broken into little tiny pieces. And the little tiny pieces are going to be remolded back into these simpler atoms again. And that's all it's doing. It's a grinder. At the same time as it's making stuff, at the same time it's breaking stuff apart, because it's just so hot because of the gravity. So the very thing they're just ignoring, this huge force that's just completely consuming any idea. It's like this was through the second law of thermodynamics, that somehow everything's falling apart, when here clearly suns are building. But they break the bricks first. You throw in a building, they break it into bricks, and then they remake a new building. That's what the sun is doing. But it's hot not because it's converting hydrogen into helium. It's hot because it's big, and its gravity is creating a ton of pressure, and pressure is heat.
Source of all life on Earth. But how is it made? It's all to do with the forces inside the atoms that make up most of the sun. Hydrogen. This is how it works. The nucleus...
So this is how it works, is the hydrogen is just electrons and protons. So again, it's all you're stuck with. And the point is you have to smash them into the frickin' neutrons. That's what the sun is making. It's making neutrons. The fact that you can make neutrons into helium, and then the helium can be converted into something else, and that can be converted into something else, that has nothing to do with it. And as he'll point out, I think later in this video, there's too much helium in the sun. So in a sense, the helium can't be what it's making. It has to be what it's made of, in the sense that that's one of the elements it broke everything down into. So big heavy elements went in, just like their experiment, where they broke the nitrogen into oxygen and a hydrogen atom. The same thing is happening to the heavy metals that went into the sun, is they got broken down. And what did they break down into? Well, yes, obviously they broke down into lithium and then helium, and right all down the scale. all the way down to hydrogen. So there's plenty of helium, but that helium wasn't helium when it went into the sun. It was some other gold. It was something else that ended up getting broken down piece by piece into helium. So they don't have any of this right either.
Of a single atom of hydrogen consists of just a proton. And every now and again, inside the high pressure, high temperature cauldron of the sun, this proton can get squeezed up close to another, and bang, the strong nuclear force kicks in and fuses them together.
So there's no, the magic for the holy, what did I call it? The ghostly ghoster. I don't know. Yes, it magically shoves protons together. It's just too ridiculous. It's not a sensible explanation. What I would argue is obviously happening is these things are under intense pressure, and the pressure is just forcing the matter to closer and closer proximity. And once you get those electrons and protons close to each other, they can't jiggle out of seeing each other. Like this, the two protons are sitting out here and the electrons here, and they're jiggling too much. You could sort of understand that, well, they jiggle both down, the protons see each other, they run away again. So it's always wobbling and balancing at a distance. But if I put it under enough pressure and I smash them close enough, well, now the two protons and the electron are so tightly bound to each other, it takes a tremendous amount of energy to push them, because they're going this way so fast and hard. They're vibrating this way so much that they can't be vibrated up and down without using more and more energy to cause those vibrations. So in a sense, their attraction is stronger than their wobble, so they never see each other and they stay very close together. That's the rational explanation. All right, well, we're all right time-wise, an hour. All right, well, we'll call that. Well, we'll do a little more.
Now, this is a process that eventually leads to the creation of a helium atom, and it's accompanied by the release of energy as a burst of light and heat.
So this obviously, this burst of energy, the sun is frickin' 7,000 degrees Kelvin or something. It's insanely hot. So what's the difference? But obviously this is all part of the system of jiggling all of this stuff that pieces will be constantly trying to escape. All right, and the gravity is the only thing, the pressure being in. So there's an equilibrium of the stuff pushing out and the stuff pushing in. And in the end, the sun ends up radiating a bunch of light. But what is the light? The light is how much the surface is jiggling. That's the bottom line. The bottom line is the sun is also doing what everything else is doing in the universe. It's reflecting. And the thing that makes something radiate photons is jiggling fast enough. So if you heat me and get my surface atoms jiggling, that is the electrons pushing in and out constantly at high rates, then I'll be producing photons. But I won't be making the photons. The photons are being made by the energy coming in. Now obviously the sun, because it is consuming stuff, okay, it does produce stuff out, but most of it is a reflection. It can't do much else but just reflect, and it's reflecting at a higher, it's taking stuff coming in, like a radio wave comes in and it comes back as a visible photon. That's the idea.
It's a bit like slamming two cymbals together and releasing a burst of sound.
It's really not. So, because the sun isn't getting colder. It's constantly doing this. It's running constantly. All right, it isn't using up some store of energy. It's constantly being refueled by the gravitational pressure. Just as the center of the Earth is molten and it stays molten, as long as the Earth is a big object in space, it's going to stay molten because the external pressures keeps feeding the furnace, keeps heating it. And that's all you're seeing is the byproduct of the heat.
Hydrogen fusing into helium, and the energy released is what we see and feel as sunshine.
So that's really not the story. You're seeing the fact that the sun is 7,000 degrees and that it's so hot that there's no surface crust hiding you from the molten core, so to speak. So let's take the crust of the earth off, all right? And then you could see it would be shining, okay? It would be glowing in the universe because you could see its heat. And it's only because the earth is covered in these heavy elements and atoms that that intense heat at the center of the earth at 2,000 degrees Kelvin can't be seen. You can't see the light the earth is producing because it can't get through the crust. And so it's just because there's a crust, and there can't be a crust on the sun because it's too hot to have a crust. It's kind of that simple.
This process of two hydrogen nuclei slamming together and releasing energy became known as nuclear fusion.
So certainly fusion's happening, but fission is happening. They're both happening. The sun is breaking and remaking, breaking and remaking. That's all it's doing. It's making as much stuff as it is destroying. It's degrading atoms into simpler atoms as much as it's making new atoms. The sun didn't absorb suns to become the sun. The sun absorbed a bunch of meteors, okay? The same crap the earth is made out of. That's what the sun absorbed. And obviously it doesn't have any of that crap anymore, those heavy elements, because it melted them down to nothing. It alchemied them.
The turmoil between the strong nuclear and electromagnetic forces as they strive to dominate the nucleus does more than just power the sun. It's at the heart of everything.
So just understand, the middle of the earth is a sun. There's a little sun in the middle of the earth. It's just not as hot. And that's the only difference. It's not hot enough to do the alchemy thing.
But in the late 1930s, before people figured out that story, nuclear physics did something much closer to home. In no uncertain terms, it redefined the history of mankind right here on Earth.
So again, this is so annoying that they would have this wacky, stupid music so loud that you can't hear the asshole talking. I mean, nobody could notice that, oh, maybe we ought to fix that.
The atom bomb changed everything. The excitement of pre-war scientific research, the days when physicists sang songs about their discoveries, were over. Robert Oppenheimer summed up the grim mood with these words: "The physicists have known sin, and this is a knowledge which they cannot lose."
Whatever. And we know that they also did a lot of celebrating because they, defeated the world, with their technology. Blah, 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 blah. It only became an issue when, oh, you mean the Russians have one now too? Oh, fuck. That sort of ruins the fun, doesn't it?
The terrible irony of the atomic bomb is that because of the scientist's sin, because of that knowledge that cannot be lost, something of great significance did emerge. Something that would ultimately reveal the full story of the 14 billion years of the entire universe.
Alright, I thought it was 13 billion years. Anyway, alright, now we'll call it halfway. Oh, shit. I can't remember what comes next. But anyway, you saw it. The strong force was just contrived. They just made up this stupid story. And it's because why? Nobody could think that you stick an electron between two protons and you've solved your problem. They have to be the same visual size, right? Because the charges are equal. Okay, the amount of the north side of the magnet's the same as the south side. So you know that whatever this is, this charged thing, it has to come in equal amounts. So they have to be, whether their masses are different, they have to be visually, that is, how they're force is manipulated between them, it has to be equal. So, you know, it's perfectly reasonable. You stick electron, proton, proton, electron in between, no problem. And vice versa, of course. And I don't understand how Rutherford, let's see, well, I remember what it was called. The fruitcake. I keep, fruitcake keeps, you know, it's not a fruitcake. It's the bran muffin. I don't, you know, I just can't remember. Damn, I just hate getting old. So anyway, he knew there was electrons in the nucleus. Why would you think there is such a thing as a strong, why do you need a strong force for? Just that one just surprises me that it was just invented. They just decided to invent a ghost mechanism instead of really looking for a rational answer. But anyway, till the next time and such, they'll call this a video, so I'll upload it. We'll see if they copyright it. If they do, I'll probably go all the way with the protest on this one, because really there's just no excuse for this horse shit. I mean, you know, what am I supposed to just read the transcript? You know, that's the limit of my fair use, is reading the transcript. You know, fuck this. Obviously, the BBC obviously doesn't have much respect for these basic constitutional rights and such.